All right, one other clarification I wanted to make is NADH dehydrogenase, NADH dehydrogenase, the same as NAD. So are these two molecules the same? Do they equal one another? No, they do not. They are not equal. One is an enzyme, and NADH dehydrogenase is an enzyme, and you can actually see its function. I like the name of NADH dehydrogenase because it does tell you what the substrate is, as well as the function of this enzyme. So for this enzyme, ASE, the substrate equals NADH, the function equals dehydrogenate. Dehydrogenate just means remove a hydrogen. When we talk about partially hydrogenated fats, those hydrogenated fats would have additions of hydrogen. Dehydrogenated fats would have removals of hydrogen. All right, so now we're looking at NAD or NADH. So again, are any of these the same? No. NADH, this is the reduced form, because it has the protons and electrons, and this is your oxidized form. No protons and electrons. So this enzyme is going to only bind to its substrate, which is NADH. If it bound to NAD, it's not going to have any function. All right, so what is the function of NADH dehydrogenase when it binds to NADH? Now it's going to cause that NADH to lose its hydrogen, and it will be unloaded. And now those hydrogens, which are really going to be 2 electrons and 2 protons, although it's really 1 proton and 1 proton will be in solution. These are what this enzyme is going to be unloading from NADH. It's going to be unloading that H from NAD. And now it has oxidized NADH into NAD. All right, last thing I'll mention is, remember, I mentioned where the H coming from. The H are coming from those hydrogen atoms that are in your original molecule of glucose. Really, metabolism is harvesting all of those hydrogens because there are protons and electrons. Or your enzymes will use those protons and electrons, the energy in those, to transform ADP and PI into ATP. So they're using the proton and electron energy to bond ADP and PI together to produce ATP. All right. That is it for that one.